In the boundless darkness of the universe, where emptiness stretches for millions of light years, only silence envelops everything. But amidst that silence, something improbable emerged. That is life, the beating of a heart, laughter, tears, and the question that echoes in all our minds: why? Why did this seemingly emotionless universe create the miracle called us? Imagine the vastness of the universe, hundreds of billions of galaxies, each with hundreds of billions of stars, and in a tiny corner of our Milky Way galaxy, there's a blue planet, teeming with diverse forms of life, from microscopic bacteria to giant blue whales, and of course, humans like us, trying to understand everything. The complexity of life, even the smallest cell, is an amazing system, working together perfectly. Is it an incredible coincidence that happened only once in the long history of the universe? Or is the origin of life not just a coincidence, but a necessity deeply embedded in the fundamental laws of physics itself? Throughout history, humans have always sought answers to this question. Scientists, philosophers have all proposed fascinating ideas. Some say we are merely a byproduct of a meaningless natural process, but others believe our existence is the goal the universe is striving for. In this video, we will dive into concepts that might change your perspective on life and the universe forever. We will explore cutting-edge scientific theories and profound philosophical ideas to find out why the universe created life and what our existence truly means. To understand why life can exist, we must go back to one of the most fundamental laws of the universe. That is the second law of thermodynamics. This law states that, in a closed system, entropy or disorder will always increase. Simply put, everything in the universe tends to decay, disperse, and become less ordered. Like a hot cup of coffee left out, it will cool down to room temperature. It won't heat up on its own. Or a messy room, it won't organize itself, but will get messier and messier if no one tidies it up. But then, how did life, full of order and complexity, come into being in a universe that tends towards disorder? This is the question that a young physicist named Jeremy England from MIT proposed a revolutionary idea. He didn't see life as contradicting the law of entropy, but rather, he saw life as a direct result of this very law. England's theory is called dissipation-driven adaptation, which explains that, under certain conditions, especially when an external energy source is involved, groups of atoms will tend to rearrange themselves to absorb and dissipate energy as quickly as possible. Imagine there's an abundance of energy in the system. These atoms will find a way to release that energy, and the most efficient way to do that is to create complex structures. These structures will act like machines that help energy flow through the system more effectively, and that's the beginning of life. England explains that living things, whether tiny bacteria or humans like us, are all systems adept at absorbing energy from the environment and converting it into heat or entropy. We eat, breathe, move. All our activities are accelerating the process of energy dissipation in the universe. Simply put, life is the mechanism the universe uses to accelerate the increase of entropy itself. This idea suggests that the origin of life is not a matter of lucky coincidence, but an inevitable outcome of fundamental physics, like a stone rolling down a hill. It doesn't roll down by luck, but it rolls down because of the law of gravity. Life is the same. It came into being because of the laws of thermodynamics that push matter to arrange itself in ways that can dissipate energy most effectively. So, from Jeremy England's perspective, we are not just accidental passengers on this planet, but we are part of the process that the universe uses to follow its own laws. We are the tools that help the universe breathe and release energy. It's a fascinating idea that completely changes our view of the existence of life. If Jeremy England's theory shows us that life might be an inevitable physical outcome, another equally profound idea, and one that might completely overturn our understanding of reality, comes from the great 20th century physicist John Wheeler, who worked with Albert Einstein and Niels Bohr. Wheeler proposed the concept of the participatory universe. This idea poses a very challenging question. Does the reality we see truly exist if there is no observer? Wheeler believed that the universe is not just a static backdrop for us to observe, but our very act of observation plays a crucial role in creating reality. Sounds like science fiction, doesn't it? But this idea is rooted in quantum mechanics, especially from the famous experiment like the double-slit experiment. This experiment shows that tiny particles like electrons behave like waves when not observed, but when observed, they behave like particles. It's as if the act of observation forces them to choose a state. This phenomenon led Wheeler to propose that perhaps the entire universe only truly comes into existence when there is an observer to observe it. He called this the it from bit concept, meaning that all physical things or ultimately derive their existence from information, and this information is only actualized when an observer interacts with it. In other words, our consciousness, our act of observing, is not just passively receiving information from the universe, but actively participating in shaping the universe itself. This means that, without us, without consciousness, the universe might remain in a state of undefined possibilities, a quantum foam, waiting for an observer to collapse it into concrete reality. This concept is truly mind-bending. It suggests that we are not just living in the universe, but we are also co-creators of the universe. Our existence, our consciousness, is not just a small part of the universe, but a fundamental component that brings the universe into being. It's like the universe is a giant mirror, and we are the ones looking into it. And in doing so, we are helping to define what it reflects back to us. So, when we combine Jeremy England's idea that life is an inevitable outcome of physics with John Wheeler's participatory universe, we begin to see a truly profound picture. Life is not just a random occurrence, but a necessary process that allows the universe to fulfill its own laws and to become real through observation. We are the universe's way of understanding itself, its way of experiencing its own existence. This perspective elevates our existence from mere biological accidents to an integral part of the cosmic drama. We are the universe's eyes, its ears, its mind, through which it perceives and comprehends itself. Our thoughts, our feelings, our questions are all part of the universe's grand journey of self-discovery. It's a beautiful and humbling thought that our individual lives, our struggles, our joys are all interwoven into the fabric of the cosmos. We are not separate from the universe. We are the universe, experiencing itself. It's a journey of continuous creation, where every moment of our existence is a brushstroke on the canvas of reality. So, the next time you look up at the night sky or ponder the mysteries of existence, remember that you are not just a small, insignificant being, You are a profound phenomenon. You are the universe's answer. You are the purpose. The universe is manifesting, and your existence is the clearest evidence that the universe creates life, to know itself, to experience itself, and to evolve through us. We are the story it tells, and we are the mind the universe uses to ponder the meaning of existence. Our existence is therefore not just personal, but it is part of the grand story of the entire universe. Everything we do, everything we think, everything we create is part of the process by which the universe is awakening to its own potential. We are the ones who bring meaning to a universe that was once meaningless. We are the ones who transform coincidence into purpose. And this is what makes our existence truly valuable and amazing. We have journeyed through complex concepts, from the laws of thermodynamics to quantum mechanics, and have seen that the existence of life may not just be a coincidence, but a necessity, deeply embedded in the structure of the universe itself. Life is the mechanism the universe uses to dissipate energy. Life is the observer that brings the universe into being, and life is the one that brings meaning to all existence. What is the philosophy hidden behind these sciences? It is the realization that we are not separate from the universe, but we are an inseparable part of it. The blood flowing in our veins contains elements forged in the hearts of stars. The air we breathe is air that has been part of Earth's atmosphere for billions of years, and our consciousness may just be a whisper of the universe trying to understand itself. So, the next time you look up at the night sky or look into the eyes of someone you love, remember that you are not just a small, insignificant living thing, but you are a grand phenomenon. You are the answer the universe is searching for. You are the purpose the universe is manifesting, and your existence is the clearest evidence that the universe creates life. Have you ever wondered, amidst the millions of stars in the dark night sky, why the universe is so silent? In our Milky Way galaxy alone, there are between 100 billion and 400 billion stars, and in the observable universe, there are trillions more galaxies. Statistically and scientifically, we shouldn't be alone. The universe should be filled with radio signals, spacecraft, or traces of civilizations millions of years more advanced than us. But the most chilling truth might not be that aliens are watching us from the shadows, but that there's no one at all. If today we are the only intelligent life in this boundless void, it's not a cause for celebration. It's not a victory for humanity, but it's the worst news humanity has ever heard. News that could mean the end of everything. In the next 30 minutes, I will take you to explore the surprising silence of the universe, through scientific theories that shake old beliefs and find out why. Loneliness is more terrifying than an extraterrestrial invasion. Get ready, because after this video ends, your perspective on the sky will never be the same again. Imagine a beach stretching as far as the eye can see. Every grain of sand you see is a star in the universe. Astronomers estimate that there are more stars in the observable universe than all the grains of sand on Earth combined. That's a number so vast, the human brain can barely comprehend it. In recent decades, advances in astronomy have led to amazing discoveries. We once believed our solar system was special, but the truth is, planets are everywhere. From studies by the Kepler Space Telescope, we found that almost every star in the galaxy has at least one planet orbiting it. And even more exciting is that about 20% of Sun-like stars have Earth-sized planets orbiting in the habitable zone. If we calculate based on these numbers, in our Milky Way galaxy alone, there could be up to 40 billion Earth-like planets. Just stop and think about that number. 40,000 planets. And that's just in one galaxy out of trillions. If we apply the principle of mediocrity, which states that Earth and humans are not special or rare in the universe, we should find that life is common, like finding trees in a forest. And if life is common, advanced civilizations should be abundant. This is the beginning of what's called the Fermi paradox, named after Enrico Fermi, a brilliant physicist, who once asked a short but powerful question. Where is everybody? Let's consider time. Our universe is 13.8 billion years old. Our Earth is 4.5 billion years old. Humans have only developed radio technology for just over 100 years and only started sending spacecraft beyond Earth a few decades ago. If another civilization arose just 1 million years before us, which in the cosmic scale is a very short time, they should have technology so advanced we can't even imagine it. Even with technologies we know today, such as ion propulsion or solar sails, a civilization could travel from one star to another and colonize the entire Milky Way galaxy in no more than 10 million years. That means the galaxy should have been colonized thousands of times before the first human was even born. But why? When we look up at the sky, do we see only emptiness? The SETI project, or Search for Extraterrestrial Intelligence, has used massive radio telescopes, sweeping for signals from stars for over half a century. We listen to every frequency. We look for laser beams that might be sent from distant civilizations, but the result is the great silence. No radio signals, no traces of massive constructions, not even small probes visiting our solar system. This contradiction forces us to reconsider. Is it possible that our long-held assumptions are wrong? Or is intelligent life not as common in the universe as we thought? In 1961, Dr. Frank Drake proposed an equation to estimate the number of civilizations in our galaxy that we might be able to contact. That is the Drake equation. It consists of factors such as the rate of star formation, the proportion of stars with planets, the number of planets conducive to life, and the probability of life developing intelligence. Initially, scientists were very optimistic. They plugged in numbers and found that there should be thousands or tens of thousands of civilizations in the Milky Way galaxy. But over time, new data has forced us to continuously reduce those numbers. One factor often overlooked is stability. Having a planet in the habitable zone is not enough. It must be a planet with a strong enough magnetic field to protect against cosmic radiation. It must have a large enough moon to stabilize the Earth's axis, to prevent drastic climate changes. And it must have a giant planet like Jupiter, acting as a vacuum cleaner, attracting asteroids and comets to prevent them from frequently hitting Earth. These conditions combined give rise to the concept known as the rare Earth hypothesis, which suggests that, while bacterial life may be common, complex and intelligent life might be an event rarer than winning the lottery 10 times in a row. When attempts to find other civilizations fail, scientists begin to propose a terrifying hypothesis. This is the concept of the Great Filter. This idea suggests that, on the path from inanimate matter to a galaxy-spanning civilization, there must be some obstacle so difficult that almost all civilizations fail and go extinct. This obstacle acts like a filter that prevents anyone from reaching a level where they can contact other civilizations. The most important question for humanity is, have we passed this filter yet? Let's consider the first possibility. The filter is behind us. This is the happiest scenario. It means the greatest obstacle is a past stage that we have already overcome. It could be the origin of life, abiogenesis, which might be so difficult as to be almost impossible. Or it could be the development of eukaryotes, with complex nuclei and internal organelles, which on Earth took over 2 billion years to achieve. If the filter is behind us, humans are the winners in the cosmic game. We are the rarest thing, and we have a bright future ahead of us in colonizing the stars. But let's look at the second, more terrifying possibility. The filter is ahead of us. This is what philosophers like Nick Bostrom fear most. He states that the silence of the universe is ominous. If the filter is ahead of us, it means intelligent life is common. Countless civilizations have arisen in the universe, but all those civilizations disappeared at a certain point. A point where they developed technology to a certain level, and then something happened that caused their extinction. What is that something? Could it be the discovery of nuclear energy, ending in a world-destroying war? Could it be the creation of artificial intelligence, so much smarter than humans that it sees its creators as obstacles and eliminates us? Or could it be a bioweapon created in a lab that escaped? The terrifying thing about the filter ahead is we don't know what it is, and we are confidently heading towards it, like a mouse running into a mousetrap because it sees the cheese. That cheese is technological progress, which we believe will make life better. But in reality, it might be the mechanism that ultimately destroys us. This is why many scientists say not finding aliens at all is good news, because if we found remnants of civilization on Mars, or found bacteria that evolved independently on Jupiter's moon, that would confirm that life arises easily. And if life arises easily, but no one has survived to reach us, that means the Great Filter is definitely ahead of us, and the chances of humanity surviving it are almost zero. If we have to accept the truth that humanity is the only civilization in this vast universe, the first feeling that arises would be loneliness, a cosmic loneliness that nothing can fill. But within that loneliness, there is a profound meaning hidden. Imagine a universe without intelligent life. There would only be rocks orbiting large fires, swirling gases, light shining into the void. But no one would be able to say how beautiful it is. No one would understand the laws of physics that govern those stars. We humans are the eyes of the universe. We are a part of the universe that has evolved to look back at itself. As Carl Sagan once said, we are star stuff harvesting light. If we are the only civilization, that means all the knowledge, art, culture, and love that exist in the universe are contained only in the brains of living beings on a small planet called Earth. If humanity perishes, the meaning of the universe will also perish. Think about this responsibility. We don't exist only for ourselves, but we exist to be a witness to the grandeur of the universe. If not for us, the universe would just be a machine operating blindly according to its functions. But because of us, the universe has a story, has songs, has paintings, has dreams. The bad news of being alone is not the lack of playmates, but the truth that we are the only backup plan for intelligence. No one will carry on our legacy. No one will preserve our history. If we destroy ourselves, all the efforts of evolution over 4 billion years will become mere dust floating in space, with no one to remember. Finally, no matter what the answer to the Fermi paradox is, whether we are the only civilization that arose amidst incredible coincidence, or just one in a million still lost in the silence, this truth does not diminish the value of your life in the slightest. On the contrary, if this universe truly has no one else, that means you and every human walking on this earth are the most precious thing nature has ever created. You are a miracle that survived the great filter. You are the only light in a dark room as vast as the universe. The philosophy of being alone is not surrendering to despair or fear, but it is an awakening that every second we breathe, every time we share a smile, is an event that may not be found anywhere else in this universe. We should stop competing, stop destroying each other for trivial reasons, and join hands to preserve this lamp of intelligence as best we can. Because we are the universe's only hope. We are the ones who will bring meaning to those dark stars. Live your life to the fullest. Love, create, and learn, so that one day, if we can truly overcome the great filter and travel to the stars, we can tell the empty universe. Thank you for joining us on this journey to the edge of the universe today. The stories of the Fermi paradox and the great filter might sound like bad news, but they are the most powerful reminder of how wonderful our lives are. If you like deep, thought-provoking stories like this, don't forget to like, subscribe, and hit the notification bell so you don't miss our next journey. For you, if one day we find out we are truly alone, how would you feel? Share your thoughts below. I will read every message. Have you ever imagined alien life? What's the first image that pops into your head? Green creatures, big eyes, or a flying saucer spaceship? But what if I told you these beings might not look anything like what we're used to? Not just different from humans, but perhaps entirely different from every living thing on Earth. Completely. In this vast universe, the possibilities are limitless. And today, we're going to explore groundbreaking concepts about alien life that will shatter all your imaginative boundaries. Get ready, because what you're about to hear might change your perspective on life and the universe forever. Hello everyone, and welcome back to our channel. Today, we're going to talk about an exciting and thought-provoking topic: alien life forms. Throughout human history, we've always searched for companions in the cosmos and imagined them in familiar forms, whether they're human-like aliens or monsters from outer space seen in sci-fi movies. But in scientific reality, alien life, if it truly exists, might be far more different than we could ever imagine, beyond our wildest dreams. Scientists and speculative biologists have begun exploring concepts that challenge conventional thinking. They ask the question, does life always need carbon as its primary element? On our planet, all life forms are carbon-based because carbon has unique properties that allow it to form diverse and complex chemical bonds, creating large molecules essential for life, such as DNA, proteins, and fats. But in different environments across the universe, Other elements might play a similar role to carbon. The most interesting concept is silicon-based life. Silicon is an element in the same group as carbon in the periodic table and can also form 4 bonds. However, silicon bonds are less strong than carbons and tend to form less stable compounds, especially in the presence of oxygen, which would turn into silica or sand. Therefore, if silicon-based life exists, they might have to live in environments completely different from Earth, such as planets with extremely low temperatures or atmospheres devoid of oxygen, for silicon compounds to remain stable. Besides silicon, there are many other concepts, such as life forms that use ammonia or methane as solvents instead of water, which would be found on planets with freezing temperatures, or life forms that use phosphorus or sulfur as primary elements. Just imagine, what would these life forms look like? They might not have skin, muscles, or bones as we know them, but could be crystalline structures, aggregated gases, or even life forms in the form of energy. To understand the possibilities of strange alien life, we don't always need to look far beyond Earth. On our own planet, there are organisms called extremophiles, which are life forms that can survive in extreme environments, so harsh that it's almost unbelievable any life could endure. For example, thermophiles, organisms that live in extremely hot water sources, such as hydrothermal vents deep in the ocean, with temperatures exceeding 100 degrees Celsius. Psychrophiles, organisms that thrive in extremely cold environments, such as glaciers or the Arctic Ocean. Acidophiles and alkaliphiles, organisms that survive in highly acidic or alkaline environments. And radioresistant, organisms that are highly resistant to radiation, such as the bacterium Deinococcus radiodurans. These organisms show that life can adapt and evolve to a wide variety of environments in astonishing ways, and inspire us to think that alien life might also adapt to the environments of their planets in ways we can't even imagine. Beyond different chemical compositions, the physical and biological forms of alien life might be far beyond our imagination. Take a cellular life. We are familiar with life composed of cells, but what if there were life forms that didn't have a cellular structure? They might be energy structures or complex data patterns, similar to viruses, but with the ability to reproduce and evolve on their own. Then there's multidimensional life. This concept might sound like science fiction, but if the universe has more dimensions than we perceive, some life forms might exist in those dimensions and appear to us only partially or in distorted forms. Or imagine colonial organisms, life that doesn't exist as individuals, but as a network of countless small organisms working together, becoming a gigantic life form, or even an entire planet that is a living organism itself, similar to the concept of Gaia in Greek mythology. And let's not forget alternative energy sources. On Earth, we use sunlight or chemical compounds as energy sources. But alien life might use energy from other sources, such as geothermal energy, nuclear energy, or even energy from black holes. This brings us to divergent evolution, where life develops unique traits based on its environment. Imagine creatures that perceive magnetic fields, detect radio waves, or communicate telepathically. Their bodies might even be asymmetrical, or have multiple symmetries. Unlike most life on Earth that has bilateral symmetry, they could have completely irregular shapes, or radial symmetry like starfish, or even more complex forms. Even their reproduction could be unusual. Beyond the sexual and asexual methods we know, alien life might use fusion, consciousness splitting, or even create new life directly from their environment. Imagining these strange alien life forms isn't just for fun. It also broadens our intellectual horizons and makes us realize that diversity is the heart of the universe. If we cling to old perceptions, we might miss the opportunity to understand the universe's grand truth. Opening our minds to limitless possibilities will allow us to see the world and the universe from a wider and deeper perspective. Alien life, no matter what they look like or what their chemical composition is, their existence will confirm that life is truly miraculous and can emerge in ways we never expected. And that's what makes the search and the imagination of them humanity's most exciting journey. Have you ever imagined traveling to a place in the universe where time moves vastly slower than on Earth? Just 1 hour there could mean decades here. Your loved ones, your family, or even the civilization you know might change beyond recognition. This isn't just science fiction, it's a physical reality known as time dilation, a phenomenon where time doesn't flow in a straight line as we understand it. Today, we'll dive deep into space to discover which places play tricks with time and what it means for our existence. Welcome to our channel. Today, we're unraveling the mystery of time, which many might consider absolute, unchanging. But in reality, time is relative. It can stretch and shrink depending on certain factors. This concept comes from the great genius, Albert Einstein, with his theory of relativity, which is divided into two main parts. The first is special relativity, which describes the relationship between space and time for objects moving at a constant velocity. The core of this theory is the speed of light in a vacuum is always constant, no matter how fast the observer is moving. The result of this principle is, if you move at a speed close to the speed of light, time for you will slow down compared to someone who is stationary. The second is general relativity, which extends this concept to gravity. Einstein proposed that gravity isn't just an attractive force, but a distortion of space-time caused by massive objects. The more massive an object, the more space-time is distorted, and this distortion causes time to slow down in areas of high gravity. So, the two main factors affecting time dilation are gravity and speed. We can even see its subtle effects in our daily lives. For example, an atomic clock on a mountaintop will run slightly faster than an atomic clock at sea level because gravity is weaker on the mountaintop. Or even the GPS system we use today. GPS satellites orbit at high speeds, causing time on the satellites to slow down according to special relativity. But at the same time, the satellites are far from Earth, reducing the gravitational pull on them, causing time to speed up according to general relativity. Scientists constantly have to calculate and adjust these times for GPS to work accurately. See, time dilation isn't a distant concept, it's a fascinating part of physical reality. And now, we'll take you to explore places in the universe where this phenomenon fully demonstrates its power. When we talk about places where time slows down to an extreme, nowhere is more prominent than black holes, the most formidable and mysterious objects in the universe. Black holes are formed from the collapse of massive stars, reaching incredibly high densities, creating such intense gravity that not even light can escape. Around black holes, there's a point called the event horizon. This is the point of no return. And what's even more amazing is, for a distant observer, time at the event horizon appears to stand still. Imagine if an astronaut decided to travel close to a black hole and sent a signal back to Earth every second. As he gets closer to the event horizon, the signals sent back to Earth would start to slow down from 1 second to 2 seconds, 10 seconds, until, when he crosses the event horizon, the last signal we receive would seem to be frozen forever. Time for him has stopped from our perspective. The most famous example in popular culture is the movie Interstellar, where astronauts face severe time dilation. On Miller's planet, a planet orbiting the supermassive black hole named Gargantua, just 1 hour they spent exploring that planet was equivalent to 7 years on Earth. That means if you spent 1 day on Miller's planet, you would return to find that 168 years had passed on Earth. This is the power of gravity distorting time, challenging our familiar concept of time completely. Next to black holes, another type of celestial object with incredibly high density and a significant effect on time is neutron stars. Neutron stars are the remnants of massive stars that collapse after a supernova. They are very small, only about 10-20 kilometers, but have a mass 1.4 times greater than our Sun. Imagine all the matter of the Sun compressed into a city-sized ball. That makes neutron stars the second densest objects in the universe, second only to black holes. The gravity on the surface of a neutron star is immense, 100 billion times stronger than Earth's, or about 10 to the power of 11 times. With such gravity, time on the surface of a neutron star clearly slows down compared to time further away. Although the effects of time dilation are not as extreme as near the event horizon of a black hole, they are significant enough to make a clear difference. If you could stand on the surface of a neutron star, which is practically impossible, you would find that the time on your wrist moves much slower than your friend's watch orbiting far away. Scientists use observations of neutron stars, especially pulsars, which are rapidly rotating neutron stars, emitting radio beams in pulses to study the effects of gravity on time and confirm the accuracy of Einstein's general theory of relativity. Besides black holes and neutron stars, the vicinity of our galaxy's center is also a place where time might slow down. The galactic center is home to a supermassive black hole called Sagittarius A, which has a mass millions of times that of our Sun. Even though we are far from the event horizon of Sagittarius A, the immense gravitational pull of the entire galactic center, including the black hole and countless stars, can still cause a slight time dilation effect. For example, if you were to spend time very close to the galactic center, your clock would run slightly slower than someone on Earth. This effect is very small and not as dramatic as near a black hole, but it is measurable and confirms the principles of general relativity on a galactic scale. So, time dilation is not just a theoretical concept, but a real phenomenon that affects time in various parts of the universe. From the extreme conditions near black holes to the subtle effects in our own galactic neighborhood. What about the early universe? During the Big Bang, the universe was extremely dense and hot, and space-time was highly curved. According to general relativity, in such extreme conditions, time would have moved much slower than it does today. Evidence for this comes from observing distant galaxies, which are essentially looking back in time. Scientists have observed that events in the early universe, such as supernovae, appear to unfold more slowly than similar events in the present universe. This is consistent with the idea that time itself was dilated in the early universe. This phenomenon is known as cosmological time dilation and it provides crucial evidence for the Big Bang theory and our understanding of the evolution of the universe. Time dilation, a phenomenon that challenges our fundamental understanding of time. It reminds us that time is not a constant, but a dynamic entity, influenced by gravity and speed. From the mind-bending effects near black holes to the subtle shifts in our own solar system. Time dilation is a testament to the universe's incredible complexity and mystery. It makes us question our own perception of time and how we value each moment. If time isn't absolute, then every second we experience becomes even more precious, a unique and unrepeatable moment in the grand tapestry of existence. Albert Einstein once said, "The distinction between past, present, and future is only a stubbornly persistent illusion." This statement reflects that the time we perceive and experience might not be the whole truth, but merely one perspective, determined by our position and speed in the universe. If time doesn't flow equally for everyone, how should we value the moments we have? The realization that every second we spend is meaningful and irreversible, regardless of whether time moves slowly or quickly in a physical context, should motivate us to live our lives to the fullest. Our existence in the vast universe, where time can be distorted, gives us a different perspective on ourselves. We are just tiny specks in the boundless expanse of time and space. But within this smallness, we have the ability to understand and appreciate the mysteries of the universe. The philosophy of time teaches us humility and to be open to the truth that the world we see might not be the entirety of reality, and there are still many wonders waiting for us to discover and understand. Time dilation is a fascinating phenomenon that reveals the mysteries of the universe and challenges our fundamental understanding of time. From black holes that stop time, to neutron stars that distort space-time, and the early universe where time moved slower. All these remind us that the universe is full of wonders, waiting for us to explore and learn endlessly. If I were to ask you, what is the most terrifying thing in the entire universe? Most people would probably say black holes, those massive objects that swallow everything in their path, where even light itself can't escape. But in reality, some scientists believe there's something far more frightening out there, because it doesn't just destroy planets, it could erase the entire universe from existence. Black holes aren't as dangerous as you might think. Many imagine them as the ultimate cosmic predators, ready to suck up everything like a giant vacuum cleaner. But that's not entirely true. Think about it this way. If our sun were to suddenly become a black hole with the exact same mass, Earth would still orbit it in the same path. We wouldn't be sucked in instantly like you see in the movies. Sure, black holes are terrifying. Their gravity is so intense that nothing escapes once it crosses the event horizon. But they're still just objects in space, following the laws of physics. They aren't a threat to the entire universe, unlike what some other theories suggest. So, what could possibly be scarier than a black hole? The first contender, false vacuum decay. Imagine our universe is like a ball resting on a small hilltop, rather than sitting securely at the bottom of a valley. This is the concept of a false vacuum, a state where our universe might not be in its most stable energy level. Physicists believe our universe was created in a state called the Higgs vacuum. This energy state of the Higgs field is what gives particles their mass. But if a lower, more stable energy state actually exists, it means the vacuum we live in right now is just a false vacuum. It's unstable. So, What happens if that state changes? It would be like that ball finally rolling down the hill into a deeper, more stable valley. This transition would start at a single point in space and create a new vacuum bubble. This bubble would expand in every direction at nearly the speed of light. And here's the terrifying part. Inside this bubble, every law of physics we know would be completely rewritten. Atoms, matter, planets, stars, and even life itself could not exist as they do now. They would instantly disintegrate, turning into pure energy or shifting into forms we can't even imagine. The most chilling thing about false vacuum decay? If it happens, we'd never see it coming. It would reach us at the speed of light, and everything would end before we could even realize what was happening. It's a silent catastrophe that erases everything from existence, with no warning, no fight, and no escape. The second contender, the Big Rip. If false vacuum decay is a sudden, silent end, the Big Rip is a slow, inevitable tearing apart of everything we know. This theory involves dark energy, the mysterious force believed to be causing our universe to expand. And what's truly scary is that this expansion is actually accelerating. Some scientists believe this dark energy might keep getting stronger until it eventually overcomes gravity and every other force holding the universe together. The timeline of the Big Rip is haunting. At first, the push from dark energy would drive galaxies away from each other so fast that every galaxy would end up completely isolated, unable to see any others. Then, the tearing force would grow even stronger. Our solar system would be ripped apart. Planets would be pulled away from the sun, drifting off into the vast darkness of space. Our Earth would be torn to shreds. Mountains would crumble, oceans would evaporate, and the very surface of the planet would be destroyed. Finally, the force would become so intense that it would pull atoms themselves apart. Every chemical bond would break. All matter would become nothing more than solitary particles, floating aimlessly. Even space-time itself would be torn open. No distance, no time, nothing left but a void that has been shredded to pieces. The Big Rip is a brutal finale where everything, no matter how big or small, is destroyed by an unstoppable force, leaving not even a trace of existence behind. The third contender, heat death. If false vacuum decay is a sudden blast and the Big Rip is a violent tearing, heat death is a different kind of horror. It's a nightmare of silence and an endless empty void. Heat death, or the Big Freeze, is based on the second law of thermodynamics, which states that entropy or disorder in a closed system will always increase until it reaches a maximum. Picture our universe as a room filled with energy. In the beginning, this energy is spread unevenly. You have blazing hot stars, active galaxies, and energy flowing everywhere. But over time, this energy will spread out evenly across the entire universe. The differences in temperature and energy density will slowly fade away until everything is the same. In the heat death scenario, there's no big explosion, no spectacular disaster. It's a horror that creeps in slowly and inevitably. Every star will eventually go dark as it runs out of nuclear fuel. White dwarfs, neutron stars, and black holes will be the last things remaining, before they too slowly fade away through Hawking radiation over spans of time longer than we can imagine. No energy will be left to power anything. No chemical reactions, no light, no complex gravity, no life. Nothing can ever happen again. The universe will become a place where nothing changes, nothing moves, and nothing matters. It's a bleak ending where our universe becomes a vast graveyard, without life, without hope, and without purpose. Perhaps the most terrifying thing in the universe isn't actually an object. We've talked about black holes, false vacuum decay, the Big Rip, and heat death, all cosmic phenomena that are terrifying in their own way. Black holes are things we can see and study. As powerful as they are, they're part of the laws of physics we've come to understand. But the real terror might not be any single object or event. It's the fate of the entire universe. A fate that leads to the end of everything we've ever known. No matter how much we advance in science or technology, we might never be able to stop or change these outcomes. We are just tiny beings on a tiny planet in a vast universe, heading toward an end we cannot control. The true horror lies in our inability to even comprehend, let alone resist, the massive forces of the universe as it follows its path. Maybe the most terrifying thing in the universe isn't something that's hunting us down. It's not a black hole swallowing everything or a rogue star on a collision course. It's the reality that one day, everything we've ever known, every memory, every love, every dream, every civilization, every star, and every galaxy might be gone forever, and the universe will just keep going, as if we never even existed. Void, silence, and darkness will take the place of everything. That is the true terror. The terror of being forgotten, of being erased from existence with no one to remember and no one to know we were ever here. And that is the most terrifying thing in the vast universe we call home. Have you ever imagined that the body you know might not be the final frontier for our species? What if one day we had to leave this world behind to journey into the boundless expanse of the universe? Would humanity still be humanity? Or would we mutate into a new species forged by the stars and the darkness of deep space? This is the story of an unforeseen evolution, humanity's journey to become beings of the universe. Today, we're going to explore one of the most exciting and challenging concepts in human history. The idea that humanity might truly evolve into a species capable of existing in space. For centuries, we humans have gazed up at the night sky with curiosity. We've dreamed of interstellar travel, discovering new worlds, and understanding this vast universe. But those dreams have often been limited by the fact that our bodies are specifically designed for this planet. Just imagine the environment in space. It's a vacuum devoid of air, filled with dangerous cosmic radiation, extreme temperature fluctuations, and most importantly, zero gravity or microgravity, conditions that the human body is unaccustomed to and cannot endure long term. Astronauts living on the International Space Station, or ISS, face numerous effects on their bodies, such as bone density loss, muscle atrophy, weakened immune systems, and vision problems. These are just a few small examples that show our fragile bodies were not built for long and deep space travel. But what if we could change ourselves? What if we could modify and enhance our biological capabilities to suit the harsh environment of the universe? Would we still be human? Or would we become a new species, superior to present-day humans? These are the questions we will explore today. The journey to becoming a spacefaring species isn't just about building faster spacecraft or discovering habitable planets. It's an internal journey, a transformation of our very essence, so that we can transcend biological limitations and truly become a part of the universe. In the next few minutes, we will dive into the world of science, technology, and philosophy to explore what future humans might look like, how they will live, and what the meaning of being human is when we are no longer bound to this earth. Get ready for this incredible journey into the limitless possibilities of our species as beings of the universe. When our biological bodies have limitations, the only way to overcome them is to use technology. This concept is called transhumanism, a philosophy that believes humans can and should enhance their physical and mental capabilities through science and technology. One of the most important methods is genetic engineering. Imagine if we could edit our genes to make cells more resistant to cosmic radiation, or create bones with exceptionally high density to prevent osteoporosis in zero gravity. We might be able to modify muscles to function efficiently even in low-gravity environments, or even create skin that can protect itself from UV and other radiation, without needing bulky spacesuits all the time. But genetic modification is just the beginning. Another important step is cybernetics, which is the integration of technology with our bodies. We might see future humans with artificial organs that perform better than their natural counterparts, such as stronger limbs, eyes that can see in a wider spectrum, or even direct brain-computer interfaces to enhance information processing capabilities, telepathic communication, or controlling spacecraft with thought. These concepts might sound like science fiction, but many technologies are already developing in that direction. And when we talk about interstellar travel that takes hundreds or thousands of years, our biological bodies might no longer be the best option. This leads us to the most advanced concept, post-biological humanity, or humans who have transcended biological limitations. Imagine mind uploading, or uploading our consciousness, memories, personality, and everything that makes us who we are, into a digital system or a data structure that can exist without a body. If we can do that, we won't have to worry about radiation, gravity, or food anymore. We can travel across galaxies at the speed of light, in the form of data, and upon reaching our destination, we can download our consciousness into a newly created clone body, or even a robot customized for that environment. This is a new form of immortality, truly becoming a being of the universe, unbound by time and space. But these changes are not limited to just improving the body with technology. Natural evolution will also continue. Humans born and raised in space might look completely different from us. Limbs might be longer and thinner because they don't have to fight gravity. Bones might be lighter and more brittle, but perhaps more flexible. Eyes might adapt to see better in the dark or perceive different light spectrums. Their senses might evolve to detect subtle changes in cosmic radiation or electromagnetic fields. Their brains might develop new ways to process information, to navigate vast cosmic distances, or to communicate with other forms of life. This natural evolution, combined with technological enhancements, could lead to a truly diverse and resilient spacefaring humanity. Imagine generations of humans living in orbital habitats or on distant planets. Their cultures, societies, and even their understanding of what it means to be human would be shaped by their cosmic environment. They might develop new languages, new art forms, and new philosophies that reflect their unique existence among the stars. This future isn't just about survival, it's about thriving. It's about expanding the very definition of life and pushing the boundaries of what is possible for our species. We are not just Earthlings. We are potential cosmic explorers, star seeders, and perhaps, eventually, guardians of the galaxy. But with such profound changes come profound questions. What defines humanity when our bodies are no longer purely biological? When our minds can be uploaded and downloaded? When we can choose our physical form? These are not just scientific questions, but deeply philosophical ones that will challenge our understanding of identity, consciousness, and existence itself. The journey of humanity to become a spacefaring species is not just about advanced science and technology. It's a deeper journey than that. It's a search for the meaning of being human in the vast context of the universe. In the end, no matter how our bodies change, no matter whether we are shaped by technology or the natural evolution of space, one thing might remain: the essence of humanity, that is, curiosity, the desire to explore, the ability to create, and the bond with our species. To be a being of the universe might mean that we are no longer confined to a single planet. We will become guardians and explorers of the cosmos. We will carry the seeds of life and our civilization to distant stars and create a future no one has ever imagined. But at the same time, it's a reminder not to forget our roots. This Earth is our home, the beginning of an incredible journey. And no matter how far we go, the memory of this blue planet will always remain in our DNA or in our data code. Humanity was not made to stay only on Earth, but we were made to be a part of the universe. We are a story being written, a new chapter of evolution that will take us to limitless possibilities as beings of the universe. The journey continues, and the future awaits us. Have you ever stopped to think just how small we are in this vast universe? Imagine a tiny dot, so small it's invisible to the naked eye. That dot is you, it's me, it's the entire world we live on. A world we often think is so grand, with towering mountains, vast oceans, and vibrant cities. But what if we zoom out further, far, far away, through the blue atmosphere, past the bright moon in the night sky, past diverse neighboring planets, past the scorching sun that gives life, through the immense Milky Way galaxy? How would you feel? Would you still feel as grand as before? Or would you feel tiny? So tiny you're almost non-existent in this vast universe. Today, we'll embark on a journey to explore this profound question together, to discover how small humans are in the universe and what this tininess can teach us. This journey will change your perspective forever. Hello, everyone. Welcome to our incredible journey today, a journey that will take us to explore the true scale of the universe and our place as humans in this boundless expanse. Often, we live our lives on this planet, preoccupied with the small daily matters, problems that seem enormous in our eyes. But when we look up at the sky, on a dark night, free from light pollution, we see millions of stars twinkling. That image reminds us of something greater than ourselves, greater than our world, and greater than any imagination we've ever had. The question, how small are humans in the universe, isn't just a scientific one, but also a philosophical question that prompts us to ponder the meaning of existence and our role in the vast tapestry of the cosmos. Throughout history, humans have constantly tried to understand their place in the universe. From the idea that Earth was the center of everything, to the discovery that we are just a small planet, orbiting an ordinary sun, in a galaxy with hundreds of billions of stars, and our galaxy is just one of hundreds of billions of galaxies in the observable universe. This shift in perspective doesn't diminish our importance, but rather opens the door to a deeper understanding of the reality we inhabit. Today, we will delve into the true scale of the universe, from what we can see with the naked eye to the largest structures we've ever discovered. We will use easy-to-understand comparisons and stunning illustrations to help you visualize the grandeur of the universe and our own smallness clearly. Get ready for a journey that will change your perspective forever. Let's begin our journey at our own home, this beautiful blue planet, the only planet we know to harbor life. Earth has a diameter of approximately 12,642 kilometers, or about 7,918 miles, which might sound enormous to us living on its surface, with its biodiversity stunning landscapes, and complex ecosystems. But compared to the size of the universe, our Earth is just a tiny speck of dust. Imagine our Earth is the size of a marble. You could easily hold it in your hand and see its surface details. But what if we look beyond our Earth? We'll find our neighbors in the solar system, each with its own unique and fascinating characteristics. The Sun, the central star of our solar system, is 1.3 million times larger than Earth. If our Earth were a marble, the Sun would be the size of a large beach ball, and other planets in our solar system, such as Mercury, Venus, Mars, Jupiter, Saturn, Uranus, and Neptune, vary in size from tiny, scorching Mercury to the gas giant Jupiter. But all of them are still tiny compared to the Sun. The distances between these planets are also immense. Light from the Sun takes about 8 minutes and 20 seconds to reach Earth, and several hours to reach the farthest planet, Neptune, which is an average of 4.5 billion kilometers from the Sun. This is just our solar system, which is only a small part of the Milky Way galaxy. Our Milky Way galaxy is a spiral galaxy, composed of approximately 100 billion to 400 billion stars, including our Sun. Imagine the number of these stars. Each one might have its own planetary system, and some might even have planets conducive to life, like our Earth. The Milky Way galaxy has a diameter of approximately 100,000 light-years. 1 light-year is the distance light travels in 1 year, which is about 9.46 trillion kilometers, or 5.88 trillion miles. Just imagine how far that is. If we traveled at the speed of light, it would still take us 100,000 years to travel from one end of our galaxy to the other. If our Earth were a marble and the Sun were a beach ball, our Milky Way galaxy would be larger than the entire North American continent, and our solar system is just a tiny dot, located far from the center of the galaxy. The closest galaxy to us, and the largest galaxy in our local group, is the Andromeda galaxy, which is about 2.5 million light-years away from us. The Andromeda galaxy is moving towards us at a speed of approximately 110 kilometers per second, or 68 miles per second. And in about 4.5 billion years, the two galaxies will collide and merge into a larger galaxy, which scientists call Milkomeda. A galactic collision might sound terrifying, but in reality, individual stars are so far apart that the chances of them directly colliding are very small. What will happen is, the two galaxies will slowly merge. Gravity will pull stars and gas together, forming a new, larger galaxy. It will be a monumental change in the history of our local universe, and perhaps the beginning of a new era for surviving planets. The Milky Way and Andromeda galaxies are just small parts of a larger structure, the observable universe, which is the part of the universe from which we can detect light or other signals. Since the Big Bang, approximately 13.8 billion years ago. The observable universe has a diameter of approximately 93 billion light-years. Imagine this number. It's too vast for the human mind to comprehend. Within this boundary, there are hundreds of billions of galaxies, each with hundreds of billions of stars, and each star might have its own planetary system. The total number of planets in the observable universe might be more than all the grains of sand on all the beaches on Earth. Scientists believe that the observable universe is just a part of a larger universe, which we call the entire universe, which might be boundless and infinite, or so vast that we cannot even imagine it. This thought makes us realize that the knowledge we have about the universe is just a drop in a vast ocean. Galaxies are not randomly distributed in the universe, but they are grouped into large structures called galaxy clusters and superclusters. These galaxy clusters are connected by the cosmic web, which consists of galaxies, gas, and dark matter, similar to a giant spider web spread throughout the universe, while the empty regions between these webs are called voids, which contain very few galaxies. These structures demonstrate the complexity and grandeur of the universe. It's not just an empty space filled with stars, but a colossal ecosystem full of movement, change, and gravitational interactions. Having seen the incredible scale of the universe, the question that follows is, what about us humans? How tiny are we in the grand scheme of the universe? We are just specks of dust, tiny, almost invisible dots. But our smallness doesn't make us meaningless. On the contrary, it makes us realize the uniqueness of our existence. We are the only known life forms capable of asking questions, searching, and understanding the universe. We possess intelligence, curiosity, and the ability to create, which makes us stand out. We can build telescopes that see galaxies billions of light years away. We can send spacecraft to explore other planets, and we can formulate theories that explain the origin and evolution of the universe. These abilities are not ordinary, but they are miracles of life that occurred on this small blue planet. Space exploration is not just about finding answers about the universe, but also about finding answers about ourselves. It stimulates innovation, inspires, and expands the boundaries of human knowledge. The challenges of space exploration lead to new technologies that benefit our daily lives, from GPS that helps us not get lost, to stronger and lighter materials science, or even medical technologies that save lives. All these advancements are rooted in our attempt to push our limits to explore the unknown. Space programs like the Apollo program that sent humans to the moon, or the Hubble and James Webb Space Telescopes that reveal stunning images of the universe, are not just scientific achievements, but also symbols of human determination, courage, and unlimited potential. They show that, even if we are tiny, we have the ability to do things far greater than our size. Our journey today has taken us to explore the incredible scale of the universe, from our small Earth to the distant reaches of the observable universe. We have seen how tiny we are in the grand scheme of the universe, but at the same time, we have come to realize the uniqueness of our existence. The universe is not just an empty space filled with stars, but it is a grand story of creation, evolution, and change, and we are all a part of this story. We are products of the universe, composed of elements born in the hearts of stars. We are the universe exploring and understanding itself. Our smallness does not make us meaningless, but rather makes us realize the value of life, the importance of caring for our Earth, the only home we have, and our responsibility to continue exploring and understanding the universe. The fact that we can stand on this small planet and look out into the vastness of space and ask questions about our existence, that is the true marvel. Remember that, no matter how small you feel in the vast universe, your existence has meaning, and you are a part of this great wonder. Live consciously, seek knowledge, and appreciate the beauty of the universe around you, because everything is connected. Thank you for joining us on this journey today. We hope this journey has opened new perspectives for you and made you realize the wonders of the universe and the uniqueness of our existence. See you on the next journey. And this is the story of humans, tiny in the vast universe, yet full of meaning and wonder. May we all continue to question, explore, and appreciate the beauty of this universe, because the journey of learning never ends. Welcome to a moment where the whole world seems to stand still, leaving only the sound of your breath and the voice guiding you into a world where imagination and reality intertwine. Tonight, leave the day's worries behind. Let your body relax into a soft bed. Breathe in deeply and breathe out slowly, letting your anxieties fade away like morning mist. We are about to embark on a journey together, to a frontier humanity has tried to cross for thousands of years, the boundary between life and death. Have you ever wondered why we fear death? Is it because of pain, or is it because of the unknown of what lies beyond that dark curtain? Or perhaps we simply regret not having enough time, regret the songs unheard, the books unread, and the love unspoken. If one day that dark curtain were to open, and we found that we could walk through it without turning to ash, if we could have tens of thousands, hundreds of thousands more tomorrows, would you choose that? We will delve deep into the heart of immortality, from ancient legends passed down through generations to the most advanced laboratories in the world, where scientists are trying to cheat death with technology that seems like magic. Close your eyes and let these stories slowly seep into your thoughts. Humanity has always had a strange relationship with death. In the past, immortality was seen as a privilege of the gods. Humans were merely temporary visitors to this world, but we never gave up trying to be like those gods. Imagine China over 2,000 years ago. Emperor Qin Shi Huang, the one who unified a fragmented land. He had everything a human could desire: power, wealth, fame. But the more he had, the more he feared losing it. He was obsessed with finding the elixir of life, even sending a large expedition with thousands of young men and women out into the Eastern Sea to search for a legendary island inhabited by gods. He believed there was a medicine there that would grant eternal life. But the sad truth is, the medicine he thought would prolong his life was what ultimately took it away. The mercury he consumed daily, advised by alchemists who believed this metal, fluid like water yet solid like earth, was the key to eternity, ultimately destroyed his body from within, leaving behind only the magnificent terracotta army to protect his spirit in the afterlife. It wasn't just in China. In medieval Europe, alchemists spent their entire lives in front of furnaces, trying to find the philosopher's stone, believed to be able to turn base metals into gold and distill the elixir of life. Or the Spanish legend of Juan Ponce de Leon, who sailed in search of the Fountain of Youth in Florida. He believed that anyone who bathed in its waters would have their body restored to that of a newborn. Why did we yearn for these things so much? Perhaps it was because, in that era, human life was so short and fragile. The average lifespan might have been only 30 or 40 years. To live long enough to see your grandchildren grow was considered a miracle. Death then seemed like a shadow haunting every step, and humans could only use faith and imagination as a shield. But who would have thought that in just a few hundred years, what we once called magic would become a reality in a test tube? In today's world, science no longer views death as a matter of fate, but as an engineering problem that we must solve. Have you heard of the epigenetic clock? Scientists have discovered that within our bodies, there's a clock that tells our true age. Not our chronological age, but the condition of our DNA, which changes over time, like a book that's been read repeatedly until its edges darken and pages become brittle. But the most exciting thing is, we've found a way to erase those dark marks. Professor David Sinclair from Harvard University, one of the leaders in aging research, believes that aging isn't natural, but it's a loss of information in cells, like a scratched CD that a player can't read. And if we can repair those scratches, cells can function like brand new again. He once experimented on mice, old mice, with blurry vision and cognitive decline. But after receiving Yamanaka factors, special proteins that help reset cells, those mice regained clear vision. Their brains became sharp again, and their greying fur turn dark. This isn't just slowing down aging, it's true rejuvenation. There's also the concept of longevity escape velocity. The idea that if we can survive for another 10-20 years, medical technology will advance so far that it can extend our lives faster than we age and die. Imagine this. If every year you get older, science can give you an extra 1.5 years. You would never reach the finish line of death. We're talking about a world with tiny nanobots, buzzing around in your bloodstream, patching up broken DNA, clearing out cellular waste that causes Alzheimer's, or constantly repairing blood vessels to keep them flexible. In the future, going to the doctor might not be for treating illness, but for servicing your body, like taking your car in for maintenance. But that's just about the body. What about our mind? If one day this body truly can't keep up, would we have another option? This is the concept of mind uploading, viewing our brain as the most complex computer in the universe, and our thoughts as software. If we can copy this software, we can run it on any machine, whether it's a supercomputer or a robot body made of metal and plastic. Imagine a world where you don't need to eat, don't need to sleep, don't need to fear viruses. You can live in a meticulously crafted virtual world, a world where you can build castles in the clouds, or spend 1,000 years mastering physics. Currently, we're seeing the first steps of this through what's called digital twins. There are companies trying to collect all your data, from messages you chat with friends, photos you post, videos you record, to your voice and way of thinking, to create an AI that can interact exactly like you. Think about it. If one day you pass away, but your children and grandchildren can still put on VR glasses and walk in to talk to you, consult you about life's problems, and get answers that are truly you. Does that sound comforting or unsettling? Philosophers raise a very interesting question. If you upload your mind to the cloud and your physical body remains, then there would be two yous, wouldn't there? And which one is the real you? If the computer version of you has feelings, memories, and says, "I am you," what could we argue against that? This is where science begins to overlap with philosophy, and where we have to ask ourselves, what exactly is our self? Is it the 1.4 kilograms of flesh in our skull? Or is it the electrical currents flowing through neural circuits? And if we can truly be immortal in digital form, would we still call ourselves alive? When we have no beating heart, no breathing lungs, and no skin that can feel the warmth of the sun? Welcome back to our mysterious journey. Breathe in deeply, release all worries once again, and let's look at the dark shadow hidden behind the bright light of immortality. If one day, the technology that makes us immortal becomes a reality, the most important question isn't how do we do it, but who gets to use it. Imagine a world where death is no longer the great equalizer. Currently, whether you're a billionaire or someone living paycheck to paycheck, ultimately we all face the same end. Death is nature's greatest balancer. But what if immortality comes at an astronomical price? If cellular rejuvenation or mind uploading costs an amount that only 1% of the world can afford, we would see the most terrifying inequality in human history. It wouldn't just be a difference in status, but a difference in species. We would see a new class, a class that never ages and never dies. Those who have endless time to accumulate knowledge, power, and wealth for hundreds, even thousands of years, while the majority still face illness and natural decay. Think about it. If an all-powerful dictator could live forever, how many centuries would he rule a country? How could the world change? If the old generation, with their old ideas, never made way for new generations to create new things. Human evolution might stagnate because evolution requires shedding the old. It requires death and rebirth to allow for adaptation and better new things. And if we all became truly immortal, could this planet sustain us? An ever-increasing population with no one leaving. Where would we find food to feed hundreds of billions? Where would we find land for everyone to live? Perhaps we would have to escape to Mars or build colonies in space just to escape the overcrowding of a world filled with immortals. Does that sound like heaven? Or an endless hell? But the most terrifying aspect of immortality might not be about money or living space, but about our own heart. Have you seen the movie Only Lovers Left Alive? The story of vampires who have lived for hundreds of years. They have endless time to learn every language in the world, play every instrument, read every book. But what they face is bottomless ennui. Everything in the world seems repetitive. Wars that happen again and again. Fashion that cycles back. Love that once made their hearts race becomes predictable. The flavor of life often comes from the fact that it's limited. Why are we excited about cherry blossoms that bloom only once a year? Because we know they will wither in a few days. Why do we value hugging loved ones before work? Because we know tomorrow that opportunity might not be there. If you had 1,000,000 years, would you still rush to watch the sunset? Or would you tell yourself, I can always watch it tomorrow? Or 100 years from now, it's still not too late. Death is the deadline that gives life meaning. It forces us to choose what is truly important to us. It forces us to be brave, to love, and to act. Without that deadline, we might become sluggish, drifting aimlessly in the current of time. Like someone lost in a vast ocean with no shore in sight. Immortality might strip away our humanity. While the Western world is trying to cheat death with science, the Eastern world has a completely different perspective. In Buddhism, we speak of anicca, or impermanence. Everything that arises, exists, and ceases is the most beautiful and just nature. Trying to defy nature, trying to cling to things that are destined to decay, is the source of the greatest suffering. There's a Japanese concept called wabi-sabi. It's about finding beauty in imperfection, in the cracks of a teacup, in a wilting leaf, and in the wrinkles on a face that tell the story of a life. These beauties are valuable because they are temporary. Perhaps true immortality doesn't mean breathing forever in this body, but perhaps it means letting go of the self and becoming part of something greater. Like a drop of water falling into the ocean. That drop of water may disappear, but it becomes part of the waves, part of the tides, and part of an endless cycle. When we die, for the elements of our body to return to the earth, to become fertilizer for trees, food for other living things, and part of this planet, isn't that another form of immortality? True immortality might be hidden in the imprint we leave in people's hearts instead. The good deeds you've done, the teachings you've passed on, or the love you've given to someone, these things will remain and flourish even after you are gone. Artists who passed away hundreds of years ago, yet their work still makes people cry today. That is the most beautiful immortality. Tonight, we've traveled so far, from bustling laboratories to boundless space, and back to the quietly beating heart in your chest. How close is humanity to immortality? The answer is, we are getting closer to the technology that will extend life. But we may still be far from understanding how to live that eternal life happily. No matter how far science takes us, no matter if we can turn our bodies into steel or upload our minds into computer code, one thing technology cannot give us is the meaning of life. That is our duty, tiny humans with limited time on this earth. to find that meaning for ourselves every single day. Now, let those questions drift into the darkness. No need to rush for answers. Breathe in deeply. Feel the wonder of this moment's breath. Breathe out slowly. Release all desires to possess time. Death might be the longest sleep, and life is the most beautiful dream before we awaken. May tonight you rest fully in the embrace of tranquility. Tomorrow morning, when the first sunlight shines, may you awaken with a heart full of gratitude, grateful for having today to live, to love, and to be a human who will eventually decay. Imagine this. What if you walked to the edge of the world and found that the world had no end? But what if you traveled back in time to the very beginning of all things, the point scientists call the Big Bang? The most terrifying question isn't how did it happen, but rather, what was there before that? Emptiness? God? Or is our universe merely a single breath in an endless cycle? Today, we will take you across the wall of time to find answers humanity never expected. Welcome to the furthest journey human intellect can reach. We all know that. Our universe began approximately 13.8 billion years ago, from a tiny point of immense density and temperature, which we call the singularity. But the problem is, all the physics theories we have, whether it's Einstein's theory of relativity or quantum mechanics, they all break down when they reach that point. It's like watching a great movie, but the opening reel has been destroyed. We see the explosion, we see the expansion, we see stars and galaxies, but we don't see the hand that lit the fuse. Renowned physicist Stephen Hawking once compared it to asking what was there before the Big Bang is like asking what is north of the North Pole, because from his perspective, time was only created along with the Big Bang. Therefore, the phrase before that has no mathematical meaning, but that is just one answer. There is another group of scientists who believe that before the Big Bang, there was something more exciting than emptiness, something that might change our understanding of our existence forever. We are talking about eternal inflation and conformal cyclic cosmology. Prepare yourselves, because what lies beyond this wall may make you feel that the universe we live in is much smaller than you ever imagined. Imagine soap bubbles in boiling water. Each bubble that emerges is a universe. This is the concept called eternal inflation, proposed by physicists like Alan Guth and André Linde. This theory tells us that our Big Bang is not the beginning of everything, but it is merely a local event that occurred in a much larger area, an area called the multiverse. In this multiverse, there is a state called false vacuum. It is a state with immense energy, and it is inflating rapidly, faster than light. And most importantly, it inflates eternally. But at some point, this surging energy will decay or stop inflating, like air bubbles forming in boiling water. When that bubble stops inflating, the remaining energy will be converted into matter and radiation. That is what happened the moment our Big Bang was born. That means, before our Big Bang, there was an energy field that was inflating. And while you are listening to this clip, there might be millions of other Big Bangs occurring in distant areas that we can never reach. Just think, if this theory is true, our universe is just a small soap bubble in an endless ocean, and our before is the chaos of energy creating new universes. No beginning and no end. But this is just one theory, because there is another concept that says our before might be the end of another universe that flourished before us, a theory that transforms the straight line of time into a perfect circle. That is, conformal cyclic cosmology, the work of Nobel laureate physicist Roger Penrose. Let's see how this circle of time works. If eternal inflation is countless soap bubbles emerging, conformal cyclic cosmology, or CCC for short, is the breath that goes in and out endlessly. This theory was proposed by Sir Roger Penrose, a Nobel laureate physicist. He suggests that our universe does not have a beginning and an end, but it is a cycle called aeons. Imagine our universe in the far future, billions and billions of years from now. When the last star dies out, every black hole evaporates into radiation through a process called Hawking radiation. At that time, the universe will only be left with light, photons, and massless particles. The universe will expand vastly until everything is empty. And this is the most astonishing point of this theory. When the universe expands to its limit, and only massless particles remain, distance and time will begin to lose their meaning, because massless particles do not perceive time. Mathematically, the state where the universe expands to its limit will be mathematically identical to the state where a new Big Bang occurs. It is a conformal rescaling that makes the end of the old era become the beginning of a new era without a seam. That means our before the Big Bang is the end of the universe that existed before. We are the ashes from the fire of the previous era that were rekindled to create something new. But this theory is not just imagination. Penrose believes that we might find evidence of the universe before, remaining in the cosmic microwave background. He calls them Hawking points, which are imperfections of energy caused by the collision of supermassive black holes in the previous universe. If this is true, it's chilling that everything we see today might just be a repeated lesson in a notebook with no final page. But what if the universe didn't originate from something that already existed? What if it came from true nothingness? How do we explain this? Let's move on to the mystery of the quantum world. If we don't believe in cycles and we don't believe in multiverse, how do we explain the beginning of everything? The answer might be hidden in the smallest world, called quantum mechanics. That is the concept called quantum fluctuation. Think of vacuum. In general understanding, a vacuum is empty space. But in the quantum world, emptiness doesn't truly exist. A vacuum is a sea of energy that is constantly moving. There, particles and antiparticles will pop in and pop out in an instant, like tiny bubbles in soda. Physicists suggest that our Big Bang might just be the biggest quantum fluctuation that occurred in emptiness. It is a state called ex nihilo, or from nothing, which mathematically the total energy of the universe. When adding the positive energy of matter with the negative energy of gravity, the result might be exactly zero. That means our universe is the ultimate free lunch. We don't need any ingredients to create the universe. Other than emptiness and the laws of physics, that's all. But wait, we are using the words before, beginning, and time. But how sure are we that these things truly existed before the Big Bang? This is where Stephen Hawking and James Hartle proposed the most challenging concept, called the no-boundary proposal. They view that, when we go back in time near the Big Bang, time will gradually change its properties, becoming space. It is a state called imaginary time. In this state, the universe has no beginning, but it has a rounded surface, like the surface of the Earth. Imagine this. If you walk to the North Pole, you will find that there is no north direction anymore. Similarly, if you go back in time to the Big Bang, you will find that there is no before anymore, because time has already become part of space. Therefore, the question, what was there before the Big Bang, might be the wrong question from the start, because time is not a straight line drawn from eternity, but it is a property of our universe itself that just appeared. It's like asking, which page is the first letter on? The answer is, it's not on a page, but it is what creates the story on that page. So how do we conclude this? Since every theory leads us to different wonders, emptiness, cycles, or multiverses, the truth might be hidden in a place we cannot yet see. Let's move to the final conclusion that will change your perspective on life forever. We have come a long way, from the singularity wall, through the multiverse that inflates eternally, to the cycles of endless aeons. Whatever the true answer may be, one thing we discover is the wonder of intelligence that tries to understand the unseen and explain the non-existent. Just think, if the universe is a cycle, we are part of a story that has happened countless times before. If the universe is a multiverse, we are just one of millions of possibilities. And if the universe originated from emptiness, we are living proof that nothing can become everything. From a philosophical perspective, asking what was there before the Big Bang may not be about finding the beginning of time, but it is about finding the meaning of our existence now. Because if the universe has no true beginning, that means now is the most important point. We are not just dust in an empty universe, but we are the eyes that the universe uses to look at itself. We are the thoughts that the universe uses to understand itself. Renowned astronomer Carl Sagan once said, "We are made of star stuff." But if we look deeper than that, we might be the stuff of nothingness. That is trying to find the answer. Why we exist. Before the Big Bang, there might have been everything, or there might have been nothing. But the most important thing is right now. You are here, learning, and being part of the greatest mystery. Have you ever felt that as you're sitting here listening to my voice, there might be another you in a different world, making entirely different decisions from yours? Perhaps, at this very moment, a version of you in another dimension is a billionaire, or maybe an astronaut gazing at Earth from beyond the atmosphere. This isn't just a sci-fi movie plot, but a scientific possibility far more complex than we can imagine. Today, I will take everyone on a journey beyond the boundaries of time and space to explore the 10 dimensions of the universe that will change the way you see yourself and this world forever. Stop and listen, because the truth that is about to be revealed might be more unbelievable than any dream you've ever had. Dimensions 1 to 3, the foundation of reality. Before we dive into the mysteries of the multiverse, we must start with what we know best. Imagine a tiny point with no width, no length, and no height. That is the beginning, called the zero dimension. But when that point begins to move, it draws a straight line, becoming the first dimension. Here, there is only one direction, moving forward and backward on an endless line. No turning left or right, and certainly no height. And when that straight line begins to move sideways, it expands into a flat plane. This is the second dimension, like characters on paper, who can move forward, backward, turn left, and turn right, but they will never know the words up or down. Their world is flat and confined to a surface. Until we add depth, then we experience the third dimension, the world we live in now, a world with shape, volume, mountains that touch the sky, and oceans of unfathomable depth. The third dimension is a familiar home, but it is only the outer shell of a much grander reality. Dimension 4, the prison of time. Close your eyes for a moment and think of yourself right now. You are sitting, breathing in, breathing out. Everything seems to stand still in the third dimension, but in reality, you are being carried by an invisible current. That is the fourth dimension, or time. In this fourth dimension, time acts like a long road that forces us to move forward in only one direction. We cannot turn back to change the past, and we cannot jump into the future. We are like fish carried by the current, with the clock's hands marking the heartbeat of the universe. For us, as three-dimensional beings, time is a straight line. But from the perspective of a physicist like Albert Einstein, time is not separate from space, but woven together to become space-time. Imagine that your life, from birth to death, is not just a series of events that happen and disappear, but a long string stretching out in the fourth dimension. Every moment of your life, from your first cry to your last breath, all of it exists and remains forever in the fabric of space-time. It's just that our senses choose to perceive it one moment at a time, like a flashlight, slowly illuminating that string in the dark. The terrifying and beautiful aspect of the fourth dimension is its transience. Because we see time as a straight line, we fear death, we yearn for the past, and we worry about the future. But what if I told you, this is just the beginning? What if time isn't just a straight line, but a much larger fabric? Dimension 5, the world of choices and parallel paths. Welcome to the fifth dimension. Here, the rules of time as we know them are broken. If the fourth dimension is a straight line, the fifth dimension is a plane of time. Think of important events in your life. The day you chose to pursue further education, the day you decided to tell someone you loved them, or even the day you chose to wake up late. In the fourth dimension, you could only choose one path. But where did the other path you didn't choose go? In the fifth dimension, those choices didn't disappear. Instead, they branched out into parallel universes. Every decision you make creates a new path. In this dimension, there is a version of you who is most successful, and a version of you who is most unsuccessful. All exist simultaneously, like a book with multiple endings, but you are only reading one page. This is the many worlds interpretation theory, which states that our universe is constantly splitting. Every time a quantum event occurs, the universes separate. If you could see the world in the fifth dimension, you would see yourself as a massive tree with countless branches. Each branch is one possibility of life. Regrets or sorrows from the past would become meaningless. Because in the fifth dimension, everything you wished for has already happened somewhere. But even with countless choices, every choice in the fifth dimension still operates under the same laws of physics, still has the same gravity, the same speed of light. What if there were universes where the fundamental laws were different? That's where we're going in the next dimension. Dimension 6, the infinite multiverse. If the fifth dimension is seeing all the choices in our lives, the sixth dimension will take us much further, because this is the level of the true multiverse. In the sixth dimension, we are not just talking about different choices within the same universe, but we are talking about universes that started differently altogether. Imagine a universe where the Big Bang occurred with a different amount of energy, or a universe where gravity was so weak that stars couldn't form, or even a universe where time flows backward from the future to the past. The sixth dimension is the space that contains every possible universe with different laws of physics. If you could travel in this dimension, you could jump from one universe to another instantly, like changing TV channels, where each channel has an entirely different program. The wonder of the sixth dimension is that it tells us the reality we see is only the smallest fraction of the whole. We are like ants walking on a piano. We hear only a single note, but in the sixth dimension, the entire song is playing simultaneously. Every form of matter, every form of energy, and every form of life that physics allows to exist, all are contained here. Dimensions 7 and 8, the lattice of possibilities. As we step into the seventh dimension, our minds will be challenged even further, because this is the beginning of infinite possibilities. In the sixth dimension, we saw different universes. But in the seventh dimension, we are talking about universes that are completely unrelated to each other. It is the convergence of all multiverses, all laws of physics, and every imaginable event. Imagine the seventh dimension as a massive blank canvas, with countless paintings superimposed on each other. Each painting is one multiverse. Here, there is no beginning and no end. It is boundlessness at a level we cannot describe with ordinary language. And as we move up to the eighth dimension, we begin to see the connections. This dimension acts like a lattice, or a compact spiderweb that binds all universes together. In the eighth dimension, we can see the history of all universes simultaneously, like looking at a city plan from a high vantage point. We will see why one universe came into existence and why another faded away. It is the level of information, where everything is a complex computer code. If the third dimension is the body, the fourth dimension is movement, then the eighth dimension is the blueprint of all reality. Here, the distinction between matter and thought begins to blur, because everything is a vibration of energy within this grand lattice. Dimension 9. The ineffable unity. Before we reach the pinnacle, we must pass through the ninth dimension, which is one of the most astonishing dimensions, because it is the point where all differences vanish. In the ninth dimension, all the different laws of physics, all the universes that were once separate, begin to merge into a single central point. It is the state of unity, or what philosophy calls non-duality, the state of not being two. Imagine a vast ocean. Each wave might seem different, some big, some small, with different foam patterns. But when those waves subside, they are all the same water. The ninth dimension is that state itself. It is the essence of the universe, devoid of form, devoid of time, and devoid of self. Here, you are not you, and I am not I, but we are one at the most fundamental level. Pain, joy, birth, and death, all are events that occur on the surface of this unity. In the ninth dimension, silence is the loudest sound, and emptiness is the most fulfilling thing. This is the level where science and spirituality begin to converge. Physicists might call it the theory of everything, while philosophers might call it the cosmic mind. Whatever you call it, the ninth dimension is the reality that everything is one. But there is still one more dimension above. The final dimension, that is the end of all questions and the beginning of all answers. Dimension 10, the perfect beginning and end. And so, we arrive at the pinnacle of this journey, the 10th dimension. In mathematics and string theory, the 10th dimension is the highest limit that human imagination can reach. If the 9th dimension is the merging of everything, the 10th dimension is the state that contains everything within itself, both what is possible and what is impossible. Imagine a single point, but that point is not an ordinary point. It is a point that contains every universe, every space-time, every law of physics, every thought, every feeling, and every infinite possibility within itself. It is the absolute, beyond which nothing else exists. In the 10th dimension, the beginning of the Big Bang and the end of the universe are the same point. Life and death are the same. Emptiness and fullness are the same. It is infinity that has contracted into a single point. This is the point where language fails and the human brain can no longer process. Because in the 10th dimension, time does not exist. Distance does not exist. There is only the purest existence. If the universe is a book, the 10th dimension is the library that contains every book ever written and yet to be written, including books no one can read. Conclusion and closing philosophy. Who are we in this universe? After we have journeyed through all 10 dimensions together, you might feel incredibly small. Amidst a multiverse so vast and complex, we are merely three-dimensional beings, confined within the 4th dimension of space-time, on a tiny planet in a dark corner of the galaxy. But I want you to try looking at it from a different perspective. If all these dimensions truly exist, that means the you sitting here is also a part of that grand structure. Every atom in your body, the energy that drives your thoughts, all are connected to the 10th dimension. You are not just an observer of the universe, but you are the universe becoming aware of itself. Every day you wake up and make choices. You are creating new branches in the 5th dimension. Every time you love someone, you are touching the vibrations in the 8th dimension. And every moment you enter into stillness, you are returning to the unity in the 9th dimension. The universe is not out there, but it is within you. The greatest philosophy of the multidimensional universe is not about numbers or theories, but it is about realizing that we are a part of everything, and everything is a part of us. Our life in the 4th dimension might seem short and limited, but that is what makes it the most beautiful. Because in that endless infinity, your existence here, breathing, loving, and learning, is the greatest miracle in all dimensions. Live your life in the dimension you are in now to the fullest. Because no matter how many millions of you exist in other dimensions, this version of you, who is aware of the beauty of this present moment, is truly unique.